Hello, this is Mrs. White, and today we are going to talk about planets and gravity. Now, during our discussion today, our two essential questions are: can you describe the physical properties of planets and their locations? And we're going to talk about that throughout the video. And the second one is: can you describe the movements of the sun, planets, and the Galilean moon? So that's what we're going to be discussing today. But first, let's start with what planets are. Now, planets are celestial body moving in an elliptical orbit around the star. Now, in this lesson, we are going to look at the color, the distance of the planets from the sun, its size, speed, density, physical, and chemical makeup of each of the planets that we're going to discuss today. Now, let's start first with the inner planets. Now, inner planets compared to outer planets, the inner planets, by the way, are the following: Mercury, Venus, Earth, and Mars. Now, they're closer together in terms of their distance from each other. They're also made up of land, which is also the same term as terrestrial, and they're mostly made up of rocks and metals. Now, it is more dense, meaning it's heavier, and their size are rather smaller compared to the outer planets, and they have shorter revolution, meaning it takes them shorter amount of time to complete one revolution or until they complete their travel around the sun. And we'll talk about that later. The next are outer planets. What are the outer planets? You have Jupiter, Saturn, Neptune, and Uranus. Now, these planets are actually spread apart. They're farther apart from each other, and they're mostly made up of gas. Now, they're less dense, meaning they're lighter. If you are going to visualize it, they actually can float in water if they're like small size. Now, their size is actually very large, and it takes them a long period of time to complete one revolution around the sun, or they complete their travel around the sun longer compared to the inner planets. Now, planets are associated with gravity. Why do they stay in orbit? It is because of gravity. So, what is gravity? Gravity is a natural force of attraction exerted by a celestial body on the mass of objects that are on or near its surface. Now, how does the mass of an object affect gravity? Now, the greater the mass of an object, the more gravitational force is exerted on other objects around it. Now, what force governs all planetary movement in the solar system? Now, the sun's gravity actually is what causes the planets to orbit in our solar system, to stay in place, to revolve around the sun over and over. Now, how does the distance between two objects affect the force of gravity? Well, the closer the two objects are, the more gravitational force that they have. For example, the moon has much larger impact on our tides than the sun does, mainly because the moon is actually nearer to us. Now, let's move on to how planets move. First and foremost, planets orbit. We also call that revolve, counterclockwise around the sun. When you say counterclockwise, it moves to the left side. Clockwise is to the right. Now, all planets spin on their axis, or you call that rotation. So rotate, spins, counterclockwise except for Venus and Uranus. Now, the sun's gravity keeps them in their orbit because it pulls them towards itself. And the planets actually orbit in an elliptical shape. Now, let's move on to describing each of the planets. Let's start first with Mercury. Now, Mercury is closest planet to the sun, and it's the smallest planet. At the same time, it is the second hottest. We'll tell you what's the hottest planet. There's no atmosphere in there, meaning there's no gas in the air. And also, it takes about 88 Earth days to complete its revolution around the sun, and they believe there's a lot of craters in Mercury. Now, let's move on to Venus. Now, Venus is the second closest to the sun, and it's a sister of the Earth in terms of its size. They have the same size. It has a very thick atmosphere, which is why it is the hottest planet, because it actually traps all the heat coming from the sun because of those atmosphere blocking the heat to go back out in space. Now, it takes about 243 Earth days for Venus to complete its one revolution, or same as 1 year, and that's your Venus. The next up is Earth. Now, Earth is our home, as we all know, and it's made up of two-thirds water. Now, this is the only planet that we know to support life, although there's this Kepler 23, or an exoplanet that probably could have evidence that it could support life as well. Now, it has what you call a magnetosphere, which deflects or kind of like removes harmful electromagnetic rays coming from the sun. And it takes about 365 and one fourth Earth days to complete its revolution. Hence, that's like one full year. Next up is Mars. Now, Mars is a red planet. We call that red planet. Now, if you are familiar with Grand Canyon, they believe and they have seen and traced that Mars have what you call kind of like a Grand Canyon 2, which kind of looks like the Grand Canyon that we have here in the United States. Now, Mars sometimes have those large dust storms, and it was shown in those unmanned rovers that's currently exploring Mars. Now, it takes about 687 Earth days to complete one revolution of Mars around the Sun. Next up, Jupiter. Now, Jupiter is the largest planet. Now, it has what you call a great red spot. And in that hole, if you see that orange circular kind of looking like an eye, it can actually fit two Earths inside it, hence showing how large Jupiter is. Now, Galileo discovered many of Jupiter's moons, and Ganymede is the largest moon in the solar system, and it revolves about 12 Earth years. So it means that it takes about 12 Earth years for Jupiter to complete its one revolution around the sun. Next up is Saturn. Now, Saturn has many rings made up of dust and ice. Now, it has a very low density that if you shrink Saturn into kind of like a, I don't know, like a tennis ball, for example, it could actually float in a bathtub if it's that small. So that's how light Saturn is. And it takes about 29 years for Saturn to complete its one revolution. Next up is Uranus. Now, Uranus is an axis that is sideways, and it's interesting because the axis normally is from left to right, right to left, right? But for Uranus, it's actually sideways. It rotates north and south. And also, it has 13 rings, and some are partial rings. Now, they were able to take a picture of Uranus using the Voyager 2 that was taken in 1986, and they saw an image of Uranus. Now, it takes about 84 Earth years for Uranus to complete its one revolution around the Sun. And lastly, we have Neptune. Neptune is smaller than Uranus, but it has a greater mass than Uranus. Okay? Now, it has a great dark spot that is similar to Jupiter's great red spot, but it's called dark spot. And Voyager 2 got a chance to take a picture of it in 1989 as when it passed by. Now, it takes about 165 Earth years for Neptune to complete its one revolution around the Sun. Now, lastly, we're going to talk about the Galilean moons. So we'll start first with Io. Now, Io is the innermost moon to Jupiter, highest density, and it's the driest, most geologically active object in the solar system. So you can see here in this diagram right here, NASA's New Horizons spacecraft caught a volcanic eruption or explosion on Io. It's right here, this glare right here, the blue one. It's Jupiter's third largest moon. Next up, Galilean moons, which is another, which is called Europa. It's the smallest of the Galilean moons. It has a very smooth surface of any known solid objects in the solar system. As you can see here, the ocean moons, astronomers believe that there is this saltwater ocean under Europa's icy crust. The next one is your Galilean moon's Callisto. It's almost as big as Mercury. Same hemisphere, is always facing the Jupiter, the other side. You can't really see from Jupiter, and it's heavily cratered. And lastly, we have your Galilean moon, Ganymede. Now, this is the largest moon in the solar system, about 8% larger than Mercury, and they believe there's an underground ocean and magnetic field in Ganymede. Now, this was first observed by Galileo in 16. So, let's summarize what we learned today by writing down a short 1 to 2 sentences about what you learned from this lesson by answering these two questions. How are the inner planets' composition different from the outer planets? And how do planets move around the sun? I hope that you understand what we learned about planets and gravity. And I'll see you in class. Bye.